Hey everybody, this is my pre-lab discussion for the second lab. This lab is going to cover VSEPR modeling. Your job is to create 20 different models for 20 different molecules, and the molecules are listed on the bottom of the lab sheet. For each 20, you're going to have to do the following 7 things. First, I need you to hand draw the Lewis dot structures. Next, take the model kit and create a model, and then take a picture. I'll explain to you what you're going to do with the picture here in a second. Predict the domain geometry and molecular geometry of the model. Predict the angles based on the domain geometry, and what you want to do is draw that in over the picture that you took in part 2. Also, comment on the orbital hybridization. Now, that's not something you'll be able to do right away because we haven't talked about the hybridization yet, but you'll leave that to be done beforehand in the lab. Number 6, identify the polarity. And once again, I want you to draw the overall polarity of the molecule in on the picture. And finally, just simply comment on whether or not the molecule would exhibit resonance. I'm going to now model for you what I'm expecting you to do on this lab. So I'm going to scroll down and give myself a little bit more room. And I'm going to do everything for the molecule H2O. So I'm going to draw out the Lewis dot structure for H2O. And everybody knows, because you've drawn it 100 times, that it's 2 bonds with 2 lone pair on the central oxygen. The next thing we're going to do is take a picture and put it on in a notability so that we can draw over the top of it. I'm going to give myself a little bit more room here. But if you're looking at the directions, the next thing you need to do is predict the domain geometry and molecular geometry. Now if I'm looking at the Lewis dot structure or even the model here, I can see that there are 4 total domains around this. There are 2 bonds and 2 pair, but 4 total domains. So my domain geometry is tetrahedral. But I also need to comment on the molecular geometry. And since those 4 domains are split up 2 bonds and 2 lone pair, the shape is bent. So that takes care of number 3. Next up, I need to predict the bond angles based on the domain geometry. And you can draw that in on the picture, or you could draw it in on your Lewis dot structure. It doesn't matter. So I'm going to zoom in here on my molecular structure picture of the model, and I'm going to draw in quickly the bond angle of 109.5 based on 4 equal electron domains. Number 5 says predict the orbital hybridization, but we don't know that yet because we haven't covered it in class, so we're just going to add that in later. So the last 2 things I'm going to do are identify the polarity on the picture and make a comment on whether or not this molecule exhibits resonance. First, let's identify the polarity of the molecule. Now I'm going to use the Lewis dot structure to illustrate this. Now each bond exhibits a dipole, and in this case, since oxygen is more electronegative than hydrogen, the dipole points in from each hydrogen to the oxygen. But since the dipoles don't directly cancel each other out, this molecule has an overall dipole. And so I go in and erase the bond dipoles, and I draw in the molecular dipole to represent the polarity of the molecule. Now if the molecule isn't polar, as in the bond dipoles cancel each other out, then you just simply say nonpolar. But since this does have a bond dipole, I draw it in. Now the reason I draw the bond dipole the way I did is because hydrogen had a positive and this hydrogen had a positive pointing in towards the oxygen, but the average between them is in this space between the 2 hydrogens. They both are positive, so the central positive charge is right here. Now the arrow points towards the more electronegative atom. The negative part of the dipole lies on the oxygen, but the positive lies between the 2 hydrogens. And finally, I need to comment on the resonance of this molecule, and to answer that question, there is no resonance because there are not double bonds that can be shifted around or moved. So I'm going to do all 7 of these things, well 6, we're saving the hybridization until later, but I'm going to do all these things for each molecule, and I'm going to organize it in a neat way so that it's easy for Mr. Culmy to read, and that way I can get maximum points. You're graded on this lab based on 3 things. You'll be graded 1 point for including the name and the date. You'll be given 2 points for neatness and organization, and that is completely subjective. If I think it's not neat enough, I can take 1 or possibly 2 points away, and those really aren't arguable since it's subjective. I'm the one who decides whether it's neat or not. Finally, the remaining 7 points are if you include all the information from the methods and analysis. My final 2 notes is I'd like for you to do this in Notability if you possibly can. That way you can do hand drawings and add pictures. And also finally, since we're not doing the hybridization until Monday of next week, this isn't due until Wednesday, which happens to be the same day as your test. Anyway, thanks for listening. Have a good one.